Hi guys, little lesson on cumulative distributions. This follows on from the probability distributions that you've already done. But as the name suggests, this is cumulative. Now all of this notation, I can imagine, looks very overwhelming. Actually, it's not that difficult. It just explains what is common sense, I guess. So what you do need to know is that we use a capital F for the cumulative distribution. So if you see a capital F, you assume it's cumulative. And f of x is for just your normal PDFs, your probability distribution functions. So cumulative is always a capital F. So all this one tells us is that the cumulative distribution is the probability of x being less than or equal to x naught. So for example, if this was f of 2, this is telling me to work out all the probabilities less than or equal to 2. So it'd be cumulative. I'd have to work out 0, 1 and 2. And down here, this is saying that you sum up all the probabilities, therefore, where x is less than or equal to x naught. So you'd add up all the ones less than or equal to 2, so 0, 1 and 2. So if you want the probability that x equals 2, for example, in order to do that on a cumulative distribution, you would have to do f of 2 take away f of 1, because it would be cumulative. Okay? So f of 2 would include 0, 1 and 2. F of 1 would include 0 and 1. You take them away and you're only left with 2. I've got a couple of examples to show you. It's a lot easier when you start doing some, I promise you. So I'm going to have a look at this problem here. Probability that capital T takes the value little t. So capital T is my random variable. It can take several different values, 0, 1, 2, 3 or 4. And the probability that it takes that value is this. So we've got a little formula here. I'm going to do a table to show the probability distribution and also the cumulative distribution. And I'm going to show you how to go backwards from the cumulative distribution as well. So, firstly, let's work out those probabilities. So I've got the probability here that capital T equals little t. So this is my probability distribution. And this underneath, this is capital F of t, which is t being less than or equal to t. So this bottom one, this is the cumulative one. And this one up here will just be the individual probabilities. So that's my probability distribution. And then I want to see what it looks like when it's cumulative. So if I put 0 in here, 4 take away 0 is 4, times by a tenth, well that gives me 0.4. There we go, lovely. If I do it for the others, let's plug 1 in. 4 take away 1 is 3. I get 3/10. 4 take away 2, I get 2/10. 4 take away 3, I've got 1/10. I'm sensing a pattern here. And if I put 4 in, right, I get 0 here. And I'm just going to check that those add up to 1. 0.7, 0.9, yes, they do. Okay, so that at the top, if I was asked for the probability distribution of t, I've got it. But I want the cumulative distribution. Okay, so this one here, that's just going to be 0.4 because that's just the probability of 0. This one in here, that's going to be the probability of 0 plus the probability of 1. So that's 0.7. This one is going to be the probability of 0 plus the probability of 1 plus the probability of 2. So I have to add them all up and that gives me 0.9. This one, I think you've got the gist of it, will be the sum of all of those 4. And that adds up to 1. Next one I'm adding on 0, so I'm just going to leave 1 in there. So what I've got there in yellow is the cumulative distribution. Okay, now I'm going to show you, if you were given the cumulative distribution, how you can go back and work out the probability distribution. Okay, so here's the same table, but I've only got the cumulative distribution filled in. So there's a cumulative distribution. So sometimes they give you a formula for the cumulative distribution and they ask you to work backwards to find out what the original probabilities were. So the first one's quite easy to do, 0.4. And from there, we go all the way back here and we're using this idea here, that if I want an individual probability, I need to take away the previous one because I'm doing the running total of them. So if I want this one here, that's going to be the probability of 0 and 1, take away the probability of 0. So that will be 0.3, and I get that by doing, so 0.7 take away my 0.3 equals, sorry, take away 0.4 gives me 0.3. So that's my f of 1, and that's my f of 0. And if I do f of 1 take away f of 0, I am just left with my little f of 1. Okay? I know it's lots of new notation. It'll take a little while to get the hang of it. So this one down here, if I just want 2 by itself, this one here, remember, is probability 0 plus 1 plus 2. So if I do the probability of everything up to and including 2, take away the probability of everything up to and including 1, I'm just going to be left with 2. So 0.9 take away 0.7 is 0.2. This is the probability up to and including 3. So if I take away the probability up to and including 2, I would just be left with the individual probability of 3. And then 1 take away 1 gives me 0. So that's how you work backwards from the cumulative one to the probability distribution. Okay? So I think the notation makes it look a lot harder than it is. It's not actually that difficult. It is all this capital F and little f and things like that makes it look difficult. So have a go. Try the questions from the chapter checklist. If you struggle in any, please let me know. And what other students have been doing, they've been contacting me, showing me a picture of the work that they can't do. I've been writing some notes and sending a photo back, and we've been doing it like that. And hopefully it has been helpful. Okay, take care. Bye for now.